Good day, everyone. Our presentation today is centered on how we can use advanced wireless IoT networks to build more resilient and sustainable urban environments. This project mainly focuses on creating conceptual framework for monitoring city infrastructure in real time. I'd like to quickly introduce the team responsible for this proposal. I am Anthony Salva Mijares, project leader, and we have June Emmanuel Pineda, who focuses on development and UI conceptualization. And lastly, we have Darren Angelo Agapin, also contributing to development and interface design. And we are Techbit1001. The challenge: sustainable cities. Let's begin by establishing the context here. The push is towards sustainability, driven by SDG 11, making cities inclusive, safe, resilient, and sustainable. However, the reality of having rapid urbanization strains existing infrastructure. This strain translates into inefficient resource management, high operating costs, and unnecessary environmental stress. Simply put, our infrastructure isn't keeping up with the pace with demand and the core problem we aim to solve. Project problem and objective. Our central problem statement is that most city services, such as waste collection or utility monitoring, operate on fixed outdated schedules rather than real-time demand. So this inefficiency costs money and wastes resources. In order to address this, our project objective is to propose a conceptual framework we called SUIMS, which stands for the Smart Urban Infrastructure Monitoring System. SUIMS uses the wireless IoT technologies to collect real time data, allowing city managers to optimize services dynamically and build a truly resilient community.
Chapter 2: Key Concept. To understand how SUIMS works, we first need to review the wireless and IoT technologies that form its foundation. Core Tech, Wi-Fi 6 and IoT. The component is the backbone network for high bandwidth applications, especially in dense urban areas. IEEE 802.11ax or Wi-Fi 6 is crucial. It's used for MIMO, provides the high efficiency and capacity needed for data-heavy gateways. This network supports the IoT ecosystem, which is fundamentally broken down into three layers, such as the sensing layer. These are the actual sensors collecting the physical data like air quality or sound. Second, the network layer. This is where wireless protocols live. It's the communication backbone that moves all the data. The application layer, the cloud or central server where data is processed, analyzed, and turned into actionable, optimized commands. Specialized protocols for the job. Now let's look at specific protocols we leveraged across our system. For high density, low power applications like smart streetlights or monitoring systems, we utilized mesh networks such as Zigbee and Z-Wave. These are self-healing and conserve battery life. For our wide area network, the primary path from the city to the cloud, we rely on cellular technologies, 4G or 5G. This provides the necessary bandwidth for aggregating massive amounts of sensory data. Finally, short-range ID. Protocols like RFID and NFC are vital for assets tracking and automated utility metering, ensuring we always know the location and the status of physical resources.
Chapter 3: Conceptual Framework. With the technological foundation established, let's look at the structure of our solution: the Smart Urban Infrastructure Monitoring Systems, or as we call it, SUIMS. SUIMS three-tier architecture. SUIMS operates on a scalable three-tier architecture. The first tier is the device tier. This tier consists of low-cost battery-powered sensors using low-powered protocols like Zigbee. They sit right on the infrastructure, detecting air quality, noise, or fluid levels. The aggregation tier is the next one. These are the local collection points, which are often placed on street furniture or existing light poles. They are the bridge, meaning they collect data from multiple local sensors and they use high bandwidth connections by Wi-Fi 6 or 5G to transmit the bulk data. The last tier is the cloud tier. This is the central processing brain. It aggregates all data streams, runs machine learning analytics, and generates the real time insights that city managers use to make decisions. Application case study: Smart waste management. To illustrate this in practice, let's consider smart waste management. The classic problem is inefficiency due to scheduled routes. A truck might collect a half empty bin, wasting time and fuel, or miss a full one, causing overflow. The SUIMS solution is simple: an ultrasonic sensor which detects the bin's fill level. The sensor uses Zigbee to send its status to a nearby gateway. The gateway then uses Wi-Fi 6 or 5G to upload the data to the cloud tier. In this process, the result is huge in SDG 11. Why? Routes are dynamically optimized, leading to lower fuel consumption, reduced greenhouse gas emissions, and a cleaner, less congested urban environment. Security and resilience framework. Finally, for any urban system to be resilient, it must be secure. We propose a framework focusing on two key areas. The first of the two key areas is encryption and authentication. We must enforce strong industry standards such as WPA3 for any Wi-Fi segments and modern 5G encryption, and require mutual authentication between all devices and gateways to prevent unauthorized access. So the last key area is the isolation and integrity. Gateways must incorporate firewalls and intrusion detection systems. Crucially, we must isolate the low power sensor networks from the public internet, ensuring that data integrity is maintained at the edge. Thank you for listening, and that's all for today.